Welcome! Today we're diving into the groundbreaking world of Sora AI, OpenAI's text-to-video generator. Curious how to turn your wildest imaginations into stunning video? We'll break down the process from crafting effective prompts to understanding Sora's capabilities. Get ready to see the future of video creation. Now let's get started. Sora AI operates through a sophisticated interplay of cutting-edge technologies, primarily diffusion models and transformer architecture, adapted to handle the complexities of video generation. At its core, Sora employs diffusion models, initiating the video creation process with random visual noise. Through iterative steps, it progressively refines this noise, eliminating it until a coherent video sequence emerges that aligns with the user's text prompt. This denoising process is crucial to Sora's ability to generate realistic visuals. Complementing this, Sora leverages transformer architecture, similar to that which powers large language models. This allows the AI to understand the relationships and dependencies within the visual data, both spatially, within each frame, and temporally across the video's duration. This is vital for maintaining consistency in motion and interactions throughout the generated video. The process begins with the user providing a text prompt, which Sora's AI interprets to extract key details about the desired scene. Sora then utilizes a video compression network to transform raw video data into a more manageable latent space. This allows for efficient processing of the vast amounts of visual information. Sora works with space-time patches, small units of visual data that encapsulate both spatial and temporal information. This enables the AI to understand how objects and actions evolve over time and space. The AI adds noise to the latent space representation, and through the diffusion model, iteratively removes this noise, refining the video. Finally, the AI synthesizes the refined latent space data into a coherent video sequence. Key capabilities of Sora include its understanding of motion, simulation of the physical world, and ability to generate relatively long and complex scenes. In essence, Sora integrates diffusion models and transformer architecture to translate text prompts into videos, marking a significant advancement in AI-driven video generation. Finding truly free AI video generation tools is challenging as most platforms operate on a freemium model. This means they offer limited free access to entice users, with full features requiring a paid subscription. However, several Sora alternatives provide free options with varying limitations. Runway, for example, offers a free plan with a limited number of credits, allowing users to experiment with their AI video generation capabilities. Luma Labs' Dream Machine provides a set number of free video generations per month, enabling users to test the platform before subscribing. Kling provides free daily credits, allowing for limited video generation. Pika also offers a free option for users to test their video generation tools, with paid options providing more credits. Hyper provides a set amount of free credits to allow users to test their models. It's important to note that these free plans often come with limitations, such as restricted video resolution, length, and available features, and may include watermarks on generated videos. Additionally, many platforms use credit systems where each video generation consumes credits, and free plans typically provide a limited amount. Therefore, when exploring these alternatives, it's crucial to check their current pricing and free tier offerings as they are subject to change.